Hello and welcome to my tutorial on OCR-AS chemistry. We're talking about electronegativity and polarity today. So, a covalent bond is a shared pair of electrons. In a molecule of hydrogen, H2, the bonding atoms are identical. Each hydrogen atom has an equal share of the pair of electrons in the bond, forming a perfect covalent bond. If the bonding atoms are different from one of the atoms, it is more likely to attract bonding electrons more, so the stronger atom is considered to be more electronegative. So in hydrochloric acid, the two bonding atoms are different. The chlorine atom is more electronegative than the other atom, so the Cl atom has greater attraction for the bonding pair of electrons than H. The bonding electrons are closer to chlorine than H. So this is a polar covalent bond because that's a negative charge and a positive charge, i.e. it has two different poles. That's why it's polar. A perfect covalent bond is when the bonding pairs are shared equally between the atoms. Although I put it round in quotation marks because you never know where the electrons actually are. They're in a cloud of density in a p orbital around here and here, so they can exist wherever they want to, really, because they're so spontaneous. But it is meant to be perfect in there for the sake of learning chemistry. This is non-polar, as there is no end to the molecule. There is one polar center, and the delta negative charges all around there, but they're not equal to the carbon in the middle. So this is not polar. This is polar. This is not polar. So definitions now. Electronegativity is a measure of the attraction of a bonded atom for the pair of electrons in a covalent bond. A permanent dipole is a small charge difference across a bond that results from a difference in the electronegativities of the bonded atoms. A polar covalent bond has a permanent dipole. Permanent dipoles from van der Waals sources is the strongest. No, it's the second strongest van der Waals source that you can have, and polar molecule has an overall dipole when you take into account any dipoles across the bonds, like this. So moving on to part 2. How is electronegativity measured? A Pauling scale is used to measure electronegativity by giving more electronegative atoms a progressively larger number, with fluorine being the most electronegative here. Electronegativity increases diagonally along the periodic table up to F. So the more electronegative atom will have a slightly more than its fair share of the bonded electrons. This results in a polar covalent bond, as you can see here. Now imagine a bond between atoms of two different elements with a large difference in electronegativity. So the more electronegative atom will effectively have captured both the bonding electrons. It results in an ionic bond here. So this is more full charges this end. This is non-polar covalent bonding, so it's exactly the same. It's symmetrical if you have like atoms bonding, but this is polar, as the charges are partial. They're not permanent, they're only partial. Not as strong as ionic, but they're slightly weaker than ionic, so they're in the middle. Moving on to part 3 now. So for all of the molecules below, take the polar covalent bonds using the Pauling scale or the periodic table. So using the Pauling scale, you can easily determine which atom is going to hog the electrons more according to their number. So we'll start off with sodium chloride, and Br 2, and hydrogen bromide. So I'll give you 5 seconds and we can have a look at the answers. Okay, so NaCl, if we look at sodium's value, it's 0.93, and chlorine's value, which is 3.16, so the overall electron hogger is chlorine. Bromine has a value of 2.96, highly electronegative, but they are symmetrical, so nothing really happens when they're in a element state like that. Now hydrogen bromide, however, hydrogen is 2.2 and bromine is 2.96, so bromine is going to be slightly more electronegative than hydrogen. So I hope you found this tutorial useful. In terms of electronegativity, you've only really got to remember that it goes diagonally across the periodic table. You don't use the Pauling scale very much, but knowing that it goes like this along the periodic table helps. With fluorine being the most electronegative, one can determine the electronegativity of nearly any element on the periodic table, or you could use this periodic table by going back to the video, or I'll link it to you on my website or in the description if you would like to have it. But other than that, thank you for watching.